In today's video, I want us to understand how do we differentiate parametric equations, and what do we mean by parametric equations? What does it really mean is what we are going to understand it today. Now, in ordinary Cartesian equation, in ordinary Cartesian form, in ordinary, the one that is ordinary, in ordinary Cartesian form, so a curve may be written, so we can write it as, so I want you to stick with me until the end of this video such that you understand how we differentiate parametric equations, what are parametric equations, and I'll give you your trial question towards the end of this video. So in ordinary Cartesian form, a curve may be written as, for example, y is equal to f of x, e.g. we may say y is equal to x squared plus 2x minus, for example, 1. It may be written like this: y is equal to f of x, that is it. However, in parametric form, so in parametric form, both x and y are written in terms of a third variable that we normally call, that is called the parameter. That is normally called the parameter. So it is written with a third variable called the parameter. So that is where it derives the name parametric equations. For example, if we have, for example, you may have t equal to, you may have x as t plus 1 and y as t squared plus 3. If you look at x and y are written in the form of another parameter called, or another variable called t. This is the another variable that is not actually the x and y. So that is where it derives the name. So t is known as the parameter. So t is the parameter. So t is the parameter, and the x and y, they all depend on t. Yeah, as t varies, x and y, they also vary. That is the meaning of a parametric equation. Now we want to know, how do we differentiate a parametric equation? Now, for example, we are going to receive some examples and then we understand it fully very well. Now, for example, to differentiate a parametric equation, we normally use what we call chain rule. We use chain rule, that to get the dy by dx is the same as getting dy with respect to t times dt dx. So we simply use chain rule. This one is known as the first derivative of a parametric equation. The first derivative, and we are going to receive examples for it. So this is the first derivative. So to get the second derivative, as we are going to also see, we are going to see that to get the second derivative of the parametric equation, it is this dy, the square dy dx square, that is the second derivative, is differentiating with respect to t, but you are differentiating the first derivative times dt dx. We are going to get examples such that you clearly see this coming out very well. Let us dive into the example. Example 1. Let us receive example 1. If we are told to they have given us, they have given us, for example, x is equal to t plus 2 and y is equal to t squared plus 1. So if you have any challenge in any mathematical concept, you can use my WhatsApp. My WhatsApp is in the description of this channel, so you can contact me and you talk to me with your problem. I'll be able to solve it. So if you are told to find dy by dx, that's the first derivative. So what do? For one, we first set our chain rule. Our chain rule says that dy by dx is equal to dy by dt times dt dx. Now we have to first get dy by dt. We get dy by t by differentiating y. So our dy by dt will be differentiating this, we shall have 2t plus 0. When you differentiate a constant, you get 0. So we end up having our dy by dt as 2t. That is it. Now, when we are to differentiate when you are to get our dx dt before we get the reciprocal, we're going to differentiate it. So when you are to get dx dt, we shall have, when you differentiate this, you'll have 1. Now getting the reciprocal, which is dt dx, is actually also 1. Now we can substitute back into our chain rule. So we come and say our dy by dx is actually equal to dy by dt is 2t. So 2t times dt dx is 1. So therefore our dy by dx ends up being it is being 2t. Now if we are to get the second derivative, let me say, they have also asked us to get the second derivative. How do we get it? Second derivative, we said to get the second derivative, which is that you differentiate the first with respect to t and then times dt dx. Now to get only this, we differentiate that. So when we differentiate 2t, we get 2 times dt dx. Our dt dx is 1. Therefore our second derivative with respect to x squared is actually 2. That is it. If you clearly see the logic here is you knowing how to differentiate those ones independently. The moment you know how to differentiate those ones independently, it becomes easier for you to get anything concerning parametric equations. If you haven't subscribed, please consider subscribing. And then if you haven't liked the video, like the video, turn on the notification button, turn on the notification such that when I post the video, you can be able to see it. So this is how you quickly differentiate parametric equation. Your trial question, your trial number, the one that you are going to try out. I always want to give the one that you are going to try out. The one that says find dy by dx. So let us practice the two, also getting the second derivative. If we have the first, if x is equal to t square plus 1 and also y is equal to t power 3 minus 4. If you have any challenge in any other math concept, you can WhatsApp me, you can comment. I'll be able to try and solve your problem. Don't forget to like, hit the bell icon. We meet in the next. Thank you.